Good afternoon, everyone. This is Ben here from Computer World. I'm going to deliver a webinar to you today about VMware Site Recovery Manager, or SRM. So if we take a quick look at the agenda and what I'm going to cover today in this PowerPoint presentation. So we'll start with an overview about SRM and what the product is, and not only that, we'll talk about disaster recovery in general as well, what sort of things need to be involved. So it's not just about the technology, we need to look at the processes behind that as well and what the business needs to do to prepare for these sorts of events. So following that, we'll take a quick look at the architecture of SRM, so some of the components that makes it up, how they're configured together, what's involved with it. We'll also then take a look at some of the topologies. So if you've got multi-sites, maybe you've got a production site and a DR site, how they're configured together, or perhaps you've got a central site with lots of different sort of satellite sites around different areas of the country, how we can use those, configure those up to work with SRM as well. We'll also take a look at the deployment and configuration options, a quick run through of what's involved, along with looking at replication, the different types of replication we've got, what choices there are today. We'll then take a look at protection and recovery. So those two topics about how we protect our virtual machines, our applications that the business uses, and how we recover them if anything goes wrong in the production site. Okay, so VMware Site Recovery Manager. So the key sort of architecture is based around a production site and a recovery site. So for it to work, we need a couple of things in place first, which we'll go through shortly, but effectively it's a vSphere configuration at both sites. So we have vCenter server with hosts at the production site and the same setup at the recovery site. And then we use some form of a replication to get the data from our production site to our recovery site. So the scale of it's quite large. It can protect up to thousands of VMs. It also allows us to do things like disaster recovery testing that's not disruptive to the business. So that's a key thing, really. So when we're doing these DR tests, we don't want production workloads to suffer. There's the ability to automate it quite heavily. So that's one of the key features with SRM. If you think about all the manual processes that are involved, if building out a VMware infrastructure, SRM will take some of that hard work away from you and automate it. It's fully integrated with the VMware product stack. Due to the automation, it eliminates complexity and risks of manual process, and it just goes to that ability to get predictable RTOs. So built-in testing that we can do, we can test this on a regular basis, iron out any issues, things like that. So we're in a position to say to the business, we can recover our applications in X amount of hours. Okay, so before we dive into a deeper discussion on what SRM is, I just thought I'd talk about a service catalog. So effectively, the foundations of DR are built around the service catalog. So what it is you guys making a list of the applications that your business is using and trying to identify how much downtime each one can tolerate and how much data loss you can tolerate against each application. So on the screen now, we've got things like email system. So for example, we can tolerate a day's worth of downtime, but we can only use 30 minutes of data. Again, for SharePoint, 2 days downtime and 4 hours data loss. So by doing this exercise, what it allows us to do is build out a recovery plan, which we'll see later on in the presentation. So the recovery plan is how we get our environment back up and running as quickly as possible, and what order do we recover the applications in. So that's quite important. So the service catalog doesn't necessarily fully sit with IT in all organizations. So it's usually worked with application owners or business managers and things like that to say, if we were to suffer a loss of our production site, what applications would we need back up running first? So, email is quite a critical application now. So that's usually, top of the list. Things like, print servers and sort of low priority servers are recovered later on. So the service catalog is, like I say, key to sort of building out a DR function for the business. So this is a template. If you're interested, speak to one of our Computer World account managers. They can provide you with this if you want to use this if you haven't got one already, and we can help you build out that process. So RPO and RTO I mentioned previously. So if you're not aware, RPO is recovery point objective. So that's how much data can I afford to lose. So on the slide here, we've got a recovery point halfway through the disaster strikes. So an hour's worth of data loss is 1 hour RPO. So that means we need to snapshot our virtual machines every hour so that we can roll back to meet that objective. RTO, so that's recovery time objective, is how quickly do I need my application back up and running again. So if you think about that, you suffer a disaster, your production site, it doesn't have to be the whole site down, it might just be a rack or something like that. The applications are offline, so it's defining how quickly do I need to get those applications back up and running again. So they're the RTOs. So between them, they're the two sort of metrics we use to build out recovery plans along with the service catalog. So if we take a quick look at the architecture, so as we can see on the left here, we got our protected site. So our protected site is effectively our production site. So in there we'd have our vSphere infrastructure, so we'd have our hosts, our vCenter, platform services, controller, and there's a couple of other key components you may not have if you're not using DR already. So we're talking about SRM today, so we'll have an SRM server. Now that can be deployed, it's an application, so it can be deployed on the vCenter server. However, best practices, allow it to scale and things like that. We usually install it on a dedicated server. So on that server, if we're using array-based replication, which I'll come to in a moment, we'll install the SRA agent onto that server as well. So if we're moving down now into vSphere replication, so VMware provides their own replication appliances that you can deploy in your environment. So effectively they're just OVA files that you can deploy into your current VMware environment and configure them to replicate virtual machines on a scheduled basis. So when I'm referring to a scheduled basis, that's when we're talking about things like RPO. So say for example, I've got a file server, I want an RPO of 1 hour on that, so I'd configure replication every hour to meet that RPO requirement. So just moving down to the bottom, still on the left-hand side of this graphic, we're looking at the storage level. So many of you out there got storage arrays. So a lot of vendors will work with VMware to get their SRA adapters onto the VMware HCL, which is important. And effectively what this does is you would set up array replication between your two Equalogics, for example, your compellents. You configure the replication at the storage level. So the storage will look after the replication side of it. But the SRA effectively allows SRM to query and look inside of those volumes to see how they're replicating, what direction, etc., what VMs live on there. So it's kind of an integration into the storage layer. So if we take a look at the right side, so the recovery site, so effectively what we got here is exactly the same setup. So we're going to have a vSphere environment on the recovery site. We're going to have a vCenter over there along with an SRM server. So it's a kind of a mirrored infrastructure we got here. We would configure the replication to go from the production site to the recovery site. So typically that's usually asynchronous replication, although sometimes it can be synchronous, depending on your links. And that's the building blocks of SRM. So replication, so SRM isn't actually a replication solution itself. So it's built to work with and integrate with replication. So like I said in the previous slide, you can either do that at the SAN level or the VMware level. So typically constraints are if you've got two different storage arrays, different manufacturers, production and DR, storage replication isn't going to work for you. So that's where you'd switch back to vSphere replication. However, if you've got the same hardware at both sites, two components at either side, array-based replication may work. So there are pros and cons to both. Again, with some storage vendors, they may license you to use replication, so there may be an extra charge for that. VMware replication is part of your bundle licensing, so there's no cost for that. So the choices, they're quite flexible. So it depends on what infrastructure you've got at both sites, how much budget you've got. There are plenty of options out there to do that for you. So the primary use case for SRM is for disaster recovery. So effectively you would set up your protected site and your recovery sites together, and you'd pair them together, and you'd have your workloads running in production. So this kind of setup ensures the fastest recovery time objective. So say, for example, I want to recover my email servers quickly. I can do that and get an accurate RTA for how long that's going to take. So what this slide illustration shows here, so we get a disaster at our protected site. I think that's supposed to be a lightning strike. What would happen is the VMs would then be recovered on the recovery site, and that effectively then becomes production. So we would run our workloads from that secondary site whilst we dealt with the problems at the production site. A second use case is disaster avoidance. So this is kind of, if you know in advance there's going to be some issue with your protected site. Now that may not be a weather related incident, that could be building works, you could lose your comms or something like that, planned in advance. What you could do is fail your workload over in a controlled way to the recovery site. So it's something you know about in advance, you can plan ahead and sort of minimize that downtime. So again, that's just a case of showing us migrating our workloads over to the recovery site in a sort of controlled and organized fashion. So another use case for SRM is data center migrations. So this could be useful, say for example, you've got on-premises infrastructure at the moment, you've got your servers, you know, maybe in the basement or somewhere like that. You're going to take a rack in a data center. So if you think about the logistics of it, if you're not going to move that kit physically, it's going to stay where it is. You know, it may become your DR site effectively. How are you going to get your data from your production site into your recovery site? So we may be talking tens of terabytes here. So to push that over a WAN link, you know, in a reasonable amount of time, it's going to have to be quite a fast WAN link. So what you could do in advance is set up your new infrastructure in your hosted rack space, for example, and just start that replication off in advance, or you could even precede it, courier it there. So that just allows us to migrate the workloads from old infrastructure to new infrastructure in a sort of seamless fashion rather than doing things like lifting and shifting. So typically, what we see here compared to a lot of customers who've already got SRM deployed out there in the world have got an active passive failover. So effectively they've got a set of hardware that runs their production workloads, and then they've got a secondary site or a DR site with another set of hardware that may be SAN hosts, things like that, ready to go is standby. The downside for that is some people say, well, I'm actually paying for all this infrastructure and I'm not actually using it. The way to look at it is kind of like an insurance policy. You know, you pay for it and it's there if you need it. Another common scenario that could be achieved is, instead of having that hardware sat there, you know, not being used, could be a good opportunity for test and dev. So if you've got a test and dev environment, you've got some hardware resources that are hopefully going to be sat there not used because you're never going to have a disaster. So why not make use of them for things like, you know, test and dev. So as part of the recovery process in SRM, you can actually instruct it to power down virtual machines as well. So say, for example, you did have a development environment running at your DR site. It will consume resources, so things like CPU, RAM, disk IOPS, disk space, that sort of thing. You can actually instruct SRM to say, okay, this is non-critical workloads. You know, if we're in a DR event, we don't mind shutting down our test environment or a dev environment. So we instruct SRM to do that, and then it will recover using the resources that are available, the production workloads. So that can be a better way of using the hardware. However, there are things like licensing to consider as well. So, you know, if you want to back up or run workloads there, you need to get the appropriate licenses for that. Okay, and we just move on to the next slide. It's just a quick illustration of multi-site failovers. So effectively what we've got here is we could have a production site that's central, so it's a hub and spoke topology. We could have, you know, several different branch offices around the country, and we want to, you know, provide a DR function for those workloads. So we might need to have local workloads, you know, it might be bandwidth intensive that we don't want coming up and back up and down the WAN. So we can run them locally at that site. However, if there is a problem in that site, with a problem with the hardware, whatever that problem may be, we want to be in a position where we can recover those workloads, at the main data center. So that's an option. So you compare multiple remote offices back to one sort of central HQ. So the graphic on the bottom left just illustrates another method of doing it. This example just showing 3 different sites, and you're just replicating from A to B, B to C, and C to A, so it's sort of like a round robin fashion. So each site is running its own workloads, but it's also protecting another site. This kind of failover uses enhanced link mode, so there's VMware vSphere licensing considerations just to be aware of on this one. So we're just going to talk a bit about the concepts now. So as I discussed in some of the initial slides, there's several different components that make up an SRM infrastructure. So as we discussed, we've got the vCenter server and the SRM server. So they can be independent. Typically and more commonly, you use an external platform service controller, run them in link mode. So you share sort of a common SSO domain and then just configure SRM at both sites. So there's certain resources that we need to map together. This will help us to build out the recovery plan. So if you imagine in VMware, you've got a virtual machine, it's going to have a virtual network adapter. So what VLAN is that going to be on? What resource pool does that run in, or what host does it run against, and what policies has it got? So those are the sorts of things we need to map together. So a mapping is just, for example, we might have production VLAN 100 mapped in the protected site, and in the DR site we might have a DR VLAN 100 or something, or words to those effect. So effectively we just map them together. So what that means is the VM running in the protected site, if it were to fail over, it's no good running on the production network because that's not there anymore. So we just map that to a DR network effectively to allow that continuity. So placeholder data stores. So the way SRM works is effectively replicating the data either at the storage array level or at VMware level. So they remain offline typically whilst the volumes aren't available in the recovery site. What VMware would do is you have a placeholder data store where you effectively just store a copy of the VMX file. So if you've ever seen it or ever been on the hands-on labs, it's the normal VMware icon, but I think it's got a lightning bolt through it. So it's not actually a virtual machine, it's more of the shell. So it's just a logical way, or it gives you the ability to view what virtual machines are actually protected. So the process is when that's recovered, it will actually mount the full VM for you. So if we just move on to protection groups, I'll discuss this a bit more in a later slide, but this is just effectively the concept of grouping VMs together. So this could be anything from, you might have multiple Exchange servers, Exchange server farm or SharePoint farm. So you've got multiple VMs, so the application split across multiple VMs, and you need those to have the same RPOs and RTOs. So you don't want, data being replicated at different times and things like that. So putting them into a protection group just allows us to group all of that data together and treat it as a single entity. So the final sort of concept is the recovery plan. So the recovery plan is effectively how my environment, how my applications are recovered in the event of a DR event. So a recovery plan can contain one or more protection groups. So effectively we could have a recovery plan that would say this covers all of my VMs for a whole site failure. However, if I've got a couple of racks or a couple of applications, you might want one for Exchange, a recovery plan for SharePoint. Just if we get a failure at that single application level, or a single rack goes out or something like that, we just want to recover those workloads there. So it's very flexible in how you can recover those applications. So storage array integration. So these are provided by the storage vendors, so they work with VMware. So they need to be on the compatibility matrix, so the link's below there, but I'm sure if you Google it, you can find it. So all the common storage array vendors out there have got these. So talking about Dell, so we've got one for Compellent, Equalogic, HP have got some for their MSAs, Nimble, so on and so forth. So what the storage replication adapter does, so it discovers the arrays and it just queries the arrays to say what volumes you've got and are they replicated. So it just makes SRM aware of what's happening at that underlying storage level. So where we are at the moment with volumes in VMware, it's all transparent. The storage is transparent to the virtual machine at the moment. So, and I'm not talking about vVols, I'm just talking about normal volumes at the moment. So effectively, the virtual machine doesn't know if it's being replicated or not. So SRAs just allow that integration into the hypervisor level to say, you know, what's going on with the underlying storage. So they assist in testing and recovery. So a replicated volume from the production site to the DR site, it'll obviously be live and mounted in the production site, and it's likely to be offline in the DR site. So during testing or even failover, what the SRAs will do is SRM will talk through them to instruct the array to mount the volumes, create the initiators, and present it to VMware as a volume, so you can actually get into it and mount your virtual machines against the ESX hosts in the DR site. So, you know, it covers things like, you know, reprotect, plan migration, synchronization, things like that. So we'll go into those in a bit more detail shortly. So effectively, you have one in your DR site and one in your production site. So protection groups. So as I discussed earlier, effectively it's just a logical grouping of VMs. So some more examples here. So applications, you know, a department, specific department's got its own applications that it uses. They all need to be protected with the same RPOs and RTOs, you know, group together using a protection group. Or, you know, it's anything really. It's flexible. So it's about what the business requirement is, you know, and having the software available to allow us to meet those requirements. VM can only belong to one protection group. So that's quite important. So you're not going to be able to split it out over different protection groups. What you can do, however, as we'll touch on shortly, is have the protection group in different recovery plans. So this illustration just shows a graphical representation of, you know, we've got protection group 1, which just contains all of our web app servers. Protection group 2 contains our email servers, and group 3 contains SharePoint. What storage they are on, you know, it doesn't really matter. So it's just a logical grouping of VMs if we're using vSphere replication. If we're using storage replication, it does matter what storage LUNs they're located on. So we're just going to discuss array-based protection groups. So in here we've got a consistency group at the tops, and this is just a grouping of different data stores in VMware. So you've got data store A, data store B, data store C, and they're backed by LUN 1, 2, and 3 on the actual storage array. So if we've got our VMs that we want a protection group distributed across those 3 volumes, it's important they're all replicated together, so they've got the same replication schedule. Otherwise, they'll be, you know, out of sync. And if we've got a VM we want protecting that group that's on data store C, it's not going to work. So it just involves some planning ahead about where you deploy your VMs. So typically what we do for our customers is we use one method is a tiering. So we say, you know, we've got a tier 1 VMs, you know, they've got the shortest RPOs and quickest RTOs. They will all live together on tier 1 VMs, and they're all put into one protection group. So as I mentioned earlier, protection groups fit into recovery plans. So it's flexible. So as you can see here, you know, we've got a recovery plan 1, which just recovers our web apps. You know, 2 recovers our email. And then there's recovery plan 3, which has got all 3 protection groups in. So if we were to suffer a whole site failure, we can just invoke one recovery plan to bring all of those workloads back up. So hopefully this shows you sort of how flexible it actually is, and you've got a lot of different options and choices when it comes to creating your recovery plans. Again, it's all about meeting those business requirements, and I'll refer back to the service catalog again, because that's key. That is the piece that will dictate how you build out these protection groups and recovery plans. So we're just going to dive a bit into recovery plans themselves. So effectively what you've got is different priority groups. So you can assign applications into priority groups. So skip on a second. So effectively you've got a database. So it's in priority group 1 because it's the most important. So it's the master database. So that needs to be recovered first, because without that, nothing else is going to work. So that goes into priority 1. So priority 2 is sort of like the next step down effectively. So, we want to get other database servers back up and running. We want to get our Exchange environment back up and running. So they're next in the recovery plan. So that's priority group 2. So priority group 3 is a bit different because we've got our applications in here. However, application server 2 relies on a service that's running on application server 1. So we've kind of got that sort of ability to split out a priority group into dependencies as well. So we want application server 1 to start and that service to start before we boot up application server 2. So it allows you just to have that ability to control at a granular level what applications you want recovered in what order. So then we've got recovery group 4. So this is just going to recover Apache servers and MailSync all in one go, so it's all in parallel. And finally we've got priority group 5, which is the desktops, and they're going to be recovered all together as well. So again, they're in priority group 5 because without any of those in 1 to 4 or those application servers, there's not really much point in recovering the desktops soon if they haven't got the applications to use. So this is just a screen grab out of SRM. So in here, it's just showing you how it's configured. So we've got our ERP application here. So, we want to start 1 before 2, effectively. And you can just carry on chaining that. So if you've got, say for example, you've got a 3-tier application, you've got a database on the back end, you've got middleware, and you've got a web front end. So you want the database to come up first, followed by the middleware server, and then finally the web front end. Okay, so I've not mentioned this yet, but a key part of disaster recovery is thinking about your IP subnets. So in your production site, you're going to have your VLANs there that are routed to that physical site. It's how we deal with the networking in the DR site. So there are a couple of options. Depending on what sort of WAN links you've got, you can perhaps have stretched layer 2 networks. So they can, encapsulate those layer 2 frames, send them across on an IP network. So it's effectively a stretched VLAN. So you wouldn't need to perhaps re-IP your virtual machines in the DR site. But if you haven't, and you may be running some certain workloads in that other site, or maybe another office. So you can have people in there working, you can have VLANs and networking configured there anyway. So what do we do to address those issues of, what do we do with our IP addresses really? So effectively what SRM used to do in earlier versions is you would have to create an Excel CSV file and you would create static mappings. So, you might have an application server with one IP address and production site and you just statically assign it a secondary address. But that was quite cumbersome. So if you had a lot of VMs, there's a lot of work involved into doing a bulk import of that CSV file into SRM and configuring it that way. So I think it came out in 5.8. What we've got now is the ability to do subnet mapping. So effectively what this graphic shows is on the left we've got a subnet of 10.10.10.0. So that's our production site. And our DR site's got an address range of 192.168.1.0, both Class C network masks. So effectively, say for example, I've got a print server and it's 10.10.10.10. All we need to do is change the first 3 octets. So it becomes 192.168.1.10. So the last octet stays the same. So if you've got static IP addresses for all your different VMs, which most of us have, effectively we're just changing the network portion of it globally. So that's just a setting. So if it detects the network in production is on that subnet, it will just automatically change the IP address to the DR site network. So that takes some of the administration out of the process. It's quite easy to do. Another option is you could create this, you don't have to change your IP addresses. It can be quite cumbersome and can cause some other issues. what you could do is create a VLAN on the DR site, if you've got the ability to do that, and just have it non-routable, effectively, so it's just a layer 2 subnet. If you did suffer a DR event, you can just make that subnet routable on perhaps on your local switch, and do some changes on your internal routing infrastructure to make it route out to the internet, and that just saves re-IP addressing each VM. So that's another option. So we basically got 3. So you can either use layer 2 stretched VLANs, you can re-IP them using this new IP subnet mapping, or you can just use non-routable VLANs to do that. Okay, so shutdown and startup actions. So again, we can configure each VM differently. So some VMs might need a long time to boot. They might need to have services that take a while to start up. So we can change timeouts and things like that on there, and we can choose what happens, on a shutdown action. If we're going to do a migration, we can wait for a certain period of time for that VM to shut down, or we can use VMware tools. So typically modern servers that haven't got a lot on them, they can boot quite quickly. Once VMware tools comes up, it can detect that and move on to the next action. So pre and post power on steps, another configurable option. So we can actually have third-party scripts running for VMware. So common example of this, you've got your email servers, you might have email delivered locally, so you can have an MX record with a public-facing IP address. So as part of this, you could have a prompt that comes up to say, change your MX records, which is a manual process through your third-party service provider, and things like that. Any other public-facing interface you've got, if you've got different networking in production DR site, this can be a useful prompt. And you have to actually dismiss that prompt as part of the recovery plan to say, yeah, I made a note of that, I'll do that, and then the recovery plan will continue. So the next slide would talk about planned migration. So a planned migration is, like I said earlier, if we're perhaps moving to a data center, something like that, we've got infrastructure in place already. We can do a graceful failover effectively. So, part of the process is, we can shut down the VMs, we can synchronize the storage, the replication can happen. So we haven't got any data loss. Effectively, then we break the replication and then we bring the environment back up in the recovery site. So it's a kind of a graceful, sort of seamless process to get from one site to another. Now, obviously, there will be downtime involved in this. So, if you've got out of hours maintenance windows and things like that, you can do it in those. So this is just a graphic of what I was discussing in some earlier slides. So it's kind of the recovery steps that are available to you in these recovery plans. So using my example earlier, so we can shut down VMs. So if we're running test in dev or something in our DR site, we can configure the VMs to shut down in this policy. Effectively, what we can do is synchronize the storage in advance to reduce that downtime and configure automatically to shut down the VMs. It's just ensuring that we're not losing any data, and we've got the ability to control the order of virtual machines and how they're powered on. So if we needed to run a recovery plan, we can do testing, or it may be an actual disaster or a migration that we've got. So you notice that little hand there that says, assume it says stop, and you have to tick a box that says, yes, I really know what I'm doing. By ticking this box, I understand I'm going to, make changes to my infrastructure. So it's not an automated process. So that's a question I get quite a lot is, how does it detect my primary site's gone down? It doesn't. It's not high availability, this product as such. It's more disaster recovery. So in a disaster, it's not just the IT. Businesses are likely to have a business continuity plan or DR plan that involves a whole host of other things as well as the IT element of it. So it's normally not an IT's decision to invoke that because it's quite disruptive. It impacts everything. So it's a manual process. You don't want any sort of misconfiguration or link or something like that triggering a site failover because it would just cause chaos. So at the bottom, so if we're going to invoke a recovery, we can either do a planned migration or disaster recovery. So planned migration, we could use the example of data center migration, from production to a data center, something like that, something we know about, something we're going to do. So that will synchronize the storage and controlled way failover all of the VMs to the second site. So a disaster recovery, so effectively what that's going to do, it's going to try to replicate any recent changes, sort of fire off that last SAM replication or last VM replication. But typically, if the production environment's lost, we might not have that option. So this will just recover to the nearest point available it can. So for a forced recovery, that's a registry entry you have to change to get that box to come up. That's if you completely lost your entire production infrastructure. The building was flattened, fire, flood, whatever. That just, it just skips all checks. It just brings the environment back up from the information it's got at the DR site. So again, this slide just shows what we've already discussed really, plan migration in disaster recovery mode. So it's just some of the differences available. So, the key thing, plan migration, if it comes across any errors, it gives you the opportunity to resolve them. Perhaps my replication's not been working, there's a problem there. My replication snapshot reserve might run out of space, something I need to fix. But it's going to give you that ability to go and fix that problem to minimize the data loss. So in DR mode, you're probably not going to be worried about that. You'll probably be worried about getting your environment back up and running as quickly as possible. So it's not going to stop and check for errors. It's just going to bring it back up from what it can. So Failback. So Failback's another key concept really. So we've talked a lot at the moment about going from the production site to the DR site. So that's a one-time operation. We're moving from site A to site B. So effectively we've gone from a state of being protected and covered by a DR plan. If we were unlucky enough to have a problem at our production site, we've now failed over to our DR site, but we've lost that protection. So say for example, it wasn't actually a big disaster, maybe it was a long-term power cut or something and we lost power at our primary site. It took 12 hours to restore, whatever that may be, but we failed over to our second site. So what we could do is get our production site or original production site, site A, back up and running, and then we can use it to reprotect site B. So effectively what we're doing is reversing the process. So we're now running our production site from B and we're protecting it with A. So again, that might not be optimal. We might have older hardware in site B because it's meant for disaster recovery. It's not as fast, the storage, it's not as performant. It's just as a temporary measure, just to protect us, just to allow us to keep those applications up and running. So ideally what we want to do is go back to site A. So there's nothing wrong with it. We just lost power, for example. So we would do a failover again back to site A, but then we would just reconfigure the protection again to set it up how it was originally. So we've gone through step 1, 2, 3, and 4 effectively. So we're going from A to B, we're failing over, we've had a DR event, we're now using the original production site to reprotect our now production site, which is site B. We want to make use of our newer hardware, so we're going to fail back and then we're going to reprotect again. So it's just that process that you can go through. It's fully automated, that effectively if you're using storage replication, the storage is just, replication is just going to be reversed, so it's going to go from A to B, then B to A, and so on and so forth. So it's just that flexibility of minimizing that window where the business is unprotected from a disaster recovery point of view. So it's to sum up, what I'm trying to say is it's not a one-time process, so you can fail over and back as frequent or as little you want. So in here, as I said, this is just a slide showing the replication's gone into reverse. So instead of outgoing, it's now incoming, things like that. So it just allows you to, in SRM, to see which way the replication is going at the bottom of that graphic there. So it'll tell you which LUNs are going where, so which one's the local device and which one's the remote device. So testing the recovery plan. So this is key for DR. So there are a lot of businesses out there who maybe have backups and they haven't got DR yet, and it's how often do you test those backups? Are they reliable? Do they work for you? Having a product like SRM, just as well as giving you that protection against failure, hardware failure, service failure, whatever that may be, it's the ability to test it. So as I said earlier, it's non-disruptive. So effectively we're making use of the spare resource we've got on our second site. So we can synchronize the data across, and then we can recover that site in its entirety, or plan by plan, or however you want to do that. So one key consideration to think of as well, what about my networking? So I don't want two virtual machines online with the same name, same IP address, it causes chaos. Effectively what ESX will do is it creates I call it a bubble environment, but it's an isolated network. So we'll just create a vSwitch without any physical adapters, and it would just recover the VMs against that. So you can actually get onto it. And what you could do is, if you've got a spare NIC in some of your hosts, you could put them into a non-routable VLAN, and you just allow people then to log on to that DR recovered environment to test it. So part of that process, you might have a list of applications you need users to test that are available again. So, and part of this process can be sort of like a monthly or quarterly audit that you do. And then you can say to the business, yes, we've tested our DR recovery plan. We've managed to recover all of our servers within 4 hours. We've got users from different departments to test our applications, and they're happy, they're up and running, they can use them, they can access their data, and it can form part of a sign-off. So it's that kind of policy-based checking system that you're saying, yes, we've got this DR system, but yes, we also check it. And it just allows us to come across things like perhaps there's corruption in that replica. But by testing it, you're going to eliminate those problems and discover them, so that if you did have a DR event, you're going to know with certainty that, well, it's going to work. So it's just some steps below. You can optionally replicate the storage to bring it up to date. And it's just snapshots, either the VM or the storage, depending on what replication you're using. It mounts that snapshot to the host, it then registers the VMs on those hosts, and then powers them on in the order you determined in your recovery plan. So you want to clean up after a test recovery, because you wouldn't want to leave it running for any long periods of time, because it's consuming resources. We've got snapshots that are held open and things like that. So it's just meant to be a short-term process. So you run the recovery, test it, you get it signed off, and then you can clean it up. So effectively, it just undoes all the changes. So it power off the VMs, it removes them from the inventory, puts the placeholders back, deletes any snapshots, and just cleans it back up to bring it to that kind of vanilla state that it was in before you tested your recovery. And again, so it's either ready to test again, or it's ready there to run as production. So you've got the ability to have reports, so you can export these out into PDFs, I think, or Excel. It actually gives you statistics. So it will actually tell you how long certain plans and VMs took to recover, if there are any issues or if there are any warnings to be aware of. Perhaps you haven't got your network mapping set up correctly or things like that. So it would just, it's an audit effectively, so it would just log everything there and give you the ability to go back through your plans and see, well, when was the last time I tested, our finance recovery plan, or when was the last time I tested our exchange recovery plan, and those sorts of things. So to finish up, we've just got a couple more slides. So Site Recovery Manager is now in 6.1. So they brought out some new features at the bottom there with 6.1. So integration with NSX and stretch storage. So perhaps use it with some form of synchronous replication if you've got low latency links. You can do cross-center vMotion, and you've now got storage policy protection groups as well. So I won't go into those features today because I haven't got the time. And at the top, we've got the licensing options. So standard, maximum protection up to 75 VMs per site, and then enterprise where there's no licensing limit. So from a feature set, pretty much both the same as is, but in 6.1 you get those advanced features with the enterprise edition. Okay, time for some questions. Just check the Q&A section. Okay, it seems everybody's happy on the webinar today, so we haven't actually got any questions to answer. If you think of anything that I've not covered or you want to find out a bit more about, give us a call. I'm more than happy to have a conversation with you about, SRM or DR in general. So reach out for us, and you can get hold of us through the usual channels, really. So just to finish up, don't forget to keep an eye on our blog, Define Tomorrow, so it's www.definetomorrow.co.uk. So we publish blog posts and videos and sort of news and events on there on a regular basis, so that's where you'll find all the latest information. Okay, thanks very much for watching.